This video is all about relative molecular mass, otherwise known as MR or sometimes relative formula mass. So we're going to talk about the differences between all those different terms and make sure that you can calculate it by the end of this video. The definition of relative molecular mass is the sum of all the individual atomic masses. So what that means is if you've got a molecule, you can work out the mass of that the same as you would do for an atom. The reason that we sometimes use relative formula mass is if you've got something that's ionic. So if you've got something that's ionic, you can't really call it a molecule, so relative molecular mass doesn't really make a lot of sense. So instead, we use relative formula mass. In fact, you can imagine that basically they're the same thing as each other. MR is just a shorthand for relative molecular mass, so you just treat all three of these terms in exactly the same way. You're definitely going to need your periodic table to be able to calculate this. This is where we find the relative atomic masses. You can see it's at the bottom of each of the element boxes. So carbons is 12, hydrogens is 1. We're going to need those numbers. They're the ones I'm referring to in the examples that we're about to move on to. Right, it's example time. Firstly, let's have a look at water, or H2O. It's made up of two elements, your hydrogen and your oxygen. Hydrogen has got a relative atomic mass of 1. That's the number at the bottom of the box. I've got 2 hydrogens, so I'm going to times it by 2. The oxygen, I've only got 1 of, and it's got a relative atomic mass of 16. That's what you'll find at the bottom of its box in the periodic table. If I add those two things together, I get H2O's relative molecular mass, which is 18. All done. So nitrogen is the next one. Nitrogen has got a relative atomic mass of 14. You'll find that on the periodic table. In its molecule, I've got 2 atoms of nitrogen, so I need to times that by 2, giving me 28 as the total. Aluminium oxide is a little bit more complex. I've got a few more atoms going on here, but essentially you do the same thing. So in this, I've got 2 atoms of aluminium and I've got 3 atoms of oxygen. So that's the 26 times 2 from the aluminium, the 16 times 3 from the oxygen to give you a total of 102. The last one is calcium nitrate. So this means that I've got 1 atom of calcium, which has got a mass of 40. So that's the first thing I'll write down. But then everything in the brackets, remember, is times by that little 2 at the bottom. So that means I need to times everything in there by 2. So the nitrogen has got a relative atomic mass of 14, but I've got 2 of them because of the little 2 at the bottom of the bracket. So I'm going to times the 14 by 2. The oxygen looks like I've got 3, but wait, the 2 at the bottom means there's 2 of everything inside, so overall I've got 6 of the oxygen. So 16 from the oxygen times 6, and that gives you a total of 164. As always, here's a few for you to try. Dig out your periodic table, have a go at these 3 examples. You've got chlorine, you've got sugar, glucose, C6H12O6, and you've got calcium carbonate at the bottom. Pause, have a go at the examples. So, overall, chlorine has a relative atomic mass of 35.5. There are 2 of them, which gives you 71 in total. C6, which is 12 from the carbon times 6, then 1 from the hydrogen times 12, then 16 from the oxygen times 6. You put all of that together, you get 180. Lastly, calcium carbonate, you've got 40 from the calcium, plus the 12 from the carbon, and then you've got 3 oxygens, which gives you 100 in total. How did you do? Being able to calculate relative molecular mass is really important in chemistry. Without this, you won't be able to do a lot of the other things that are in your syllabus. So make sure that you've absolutely mastered it and that you can do any example that the exam board might throw at you.